Hey everyone, welcome to the second part of the Raspberry Pi series, Making Lights Blink. Before we get started, make sure you have viewed my setting up the Raspberry Pi video, as you will need to know how to set up and turn on the Pi. You also need to know how to open the Python 3 shell and code editor window. In this video and my next video, Morse code messages, we will be using Python to program our Pi. If you are a beginner to Python and have no experience in coding with it, then check out our Easy Peasy Python series on our channel Likeable Computing. You can also access the video through likeablestem.com. If you know Python and setting up the Pi, then let's get started. The new materials we will be using include a breadboard, GPIO pin connector wires, and an LED. A breadboard is a board with tiny holes in it, used to make electrical circuits without dealing with raw electricity or soldering irons. A breadboard is also reusable, and it makes it very easy to connect wires and electrical paths to create circuits and cool projects. GPIO, or general purpose input-output wires, are used to connect GPIO pins on the Raspberry Pi to the breadboard. An LED, or light emitting diode, is basically a light with two metal wires on the bottom that can be connected into the breadboard to complete an electrical circuit. With these materials, we'll start by putting the LED into the breadboard, then connecting it to the Raspberry Pi with the GPIO wires. The first thing we have to do is connect the GPIO wires from the Raspberry Pi into the breadboard. In order to do this, we need to know which GPIO pins on the Raspberry Pi are power pins and which pins are ground pins. To know this, you can find a GPIO pin map online at pinout.xyz, or you can use the GPIO pin map that may come with your kit. In this case, my kit came with a map, so I'll be using that.
On my map, you can see numbered pins in the middle, with values on the sides called BCM values. BCM stands for Broadcom.
First, we have to find a pin with the ground value. This will be shown on the side of a few pins with the letters G and D. If I go through the map, I can see that pin 6, the third pin on the right side, is a ground pin. I'll connect the box side of the GPIO wire to that pin. Now we have to do the same thing for the other wire. In this case, we'll be searching for a power pin, which is marked on the map by GPIO with a number next to it. There are several values on this map, but I want to choose the one that's closest to my last pin. So, I'll choose GPIO 2, which is pin number 3, the second pin on the left side. I'll go ahead and connect the boxed part of the GPIO pin connector wire to that pin on the Raspberry Pi. Now we have to connect the other end of the wires to the breadboard. First, take the ground wire that we connected to the third pin on the right side, pin 6, and plug it into the first hole all the way on the left of the row of holes directly above the blue line. This blue line distinguishes the negative row of holes from the positive row of holes shown by the red line. The ground pin sends a negative current through our electrical circuit. The other GPIO pin connector wire connected to pin 3, the second pin on the left side, sends a positive current through our circuit. So we can put it at any hole in any vertical row. We want to put it as close to the other wire as possible. So I'll put it right here. The next thing we have to do is put the LED into the breadboard. We can't put the LED into the breadboard in any way we like. We have to place it a certain way in order for us to be able to use and program it through the Pi. First, distinguish the shorter metal wire of the two wires on the LED. This goes into the hole directly to the right of your ground wire. Since the wire is shorter, this lets us know that this wire should be used to direct the negative current to the LED. Next, place the other end of the LED into any hole directly above the other wire, or the power wire. Now it's time to program the Pi. We'll be programming our Pi using Python 3 idle. To open Python 3 idle, we go to the Raspberry Pi icon in the top left corner, go down to Programming, and go down to Python 3 idle and double click on it. This will open the Python 3 shell. To open the code editor, click File, New File. The code editor is where we will be typing our code. The first few lines of code that we will be typing up are designed specifically to set up and work with the Raspberry Pi. First, we type import rpi.gpio as GPIO. This signals a monitor that we will be using the GPIO pins on the Raspberry Pi. Next, we type in import time. This enables us to use any of the time functions, such as time.sleep, in our code. Next, we type in gpio.setWarnings false. This disables all pop-ups that may appear on our screen. Next, we type in gpio.setMode gpio.bcm. This signals the monitor that we will be using the BCM values of the GPIO pins. Next, we type in gpio.setup to gpio.out. We are using the second pin on the left side to send the positive current to our LED. That has a BCM value of 2. So we type in to gpio.out since we're using that pin. Next, we type in while true, gpio.output to gpio.high. This turns the LED on. Time.sleep 1. This keeps the light on for 1 second. gpio.output to gpio.load turns the light off. The time.sleep function keeps the light off for 1 second. Since we typed in while true, this program will keep running over and over and over again until we stop running it. Now, since our code is complete, we can go ahead and run this program. To do this, just hit F5 on your keyboard. Don't forget to save your program before running. As you can see, when the program runs, The light turns on and off. Congratulations! You have now made a blinking light with the Raspberry Pi.